Hello everyone and welcome. This is Dan and today we're going to be doing a very interactive mixed exercise together. This comes from one of the past exams, so this is a good practice for the type of things that you guys will see. So let's get to it. So the graphs of f of x equals 1/2 x plus 5 squared minus 8, and g of x equals 1/2 x plus 9 over 2, and these are both sketched below. So they're telling you that A is the turning point of f, the axis of symmetry of f intersects the x-axis at E and the line G at D, and gives you those coordinates, m and n, and then C is the y-intercept of f and G. So a bunch of questions are going to be built onto this to kind of assess your knowledge. So the first thing they're going to ask you is the coordinate of A. So if we look at this, the coordinate of A is related directly to our function. So our function f of x is 1/2 x plus 5 squared minus 8. So if you remember from our talks about coordinate or quadratic equations, you know that when you have x plus 5 squared minus 8, you have, this is your a, this is your p, and this is your q. So if that's the case, then that means that your axis of symmetry, or your turning point, is going to be exactly at negative p comma q. So that means that this will be at negative 5 comma negative 8. And that will be the coordinate for your point A, which is the turning point for your graph f. Now we want to find the range of f. So if we look at this graph, we know that the domain, which is going to be the x variable, is going to be all real numbers. But for the domain, you can see that it has a minimum at A. So that means that your range has to be greater than or equal to that minimum. And this would be the range of your graph. So you can either put it this way, or you can state that negative 8 comma infinity. Okay? Now they're going to ask you for the coordinate of D. So if we look back up to this, D is going to be the intersection of your line, which is the axis of symmetry right there, and your g of x, which is 1/2 x plus 9 over 2. So what we're going to do is the axis of symmetry is located exactly at x equals negative 5. Now it's going to be equal to when g is at that point, because it has to intersect. So you're going to have g of negative 5. So it's going to be 1/2 negative 5 plus 9 over 2. This is going to work out to be negative 5 over 2 plus 9 over 2. They have the same base, so you can add them and get 4 over 2, which is just 2. So that means that your coordinates of these are going to be negative 5 comma 2. Or in other words, m equals negative 5 and n equals 2. Now it wants to know the area of OCDE. For this, we need to know a bit of information. So first of all, when we take a look at this over here, it looks like a trapezoid. And if you remember, your area of your trapezoid is half your base, or half of the sum of your bases, times the height. So the height here would be OE. And we know to go from O to E is just to go 5 units, because we know that this line with this axis of symmetry is at negative 5. So we already know that. Now, what about for DE and OC? Do we know where these are? Well, we just solved for the coordinates of D. We know that n was 2. So we know that this is a height of 2. We know that this or we know that that's a length of 2. We know that this is a height of 5. So now the only thing we need to know is where does this intersect on the y-axis. So the easy thing about this is that if you look at g of x, it's going to be intersecting when x equals 0. So that means you'll have g of 0 equals 1/2 of 0 plus 9 over 2, which is just going to give you 9 over 2. So that means that our equation is just going to be 1/2 times, and remember we had 2 for the first base. This base is now 9 over 2, and we're multiplying this by the height, which is 5. So that means that here we're going to have 1/2 of, now 2 plus 9 over 2, if we put these both into fraction forms, we have 4 over 2 plus 9 over 2 times 5, which means we're going to have half of 13 over 2 times 5. So 1/2 of 13 over 2 will give you 13 over 4 times 5, which means 5 times 13 will give you 65 over 4. And this will be your area of OCDE. Now it's asking if you can find out the inverse of g. So for this, we want to take a look at what our g was. So g of x was equal to 1/2 x plus 9 over 2. So if you remember what we used to do in order to find our inverse, we first write it down as y equals 1/2 x plus 9 over 2, and then we swap our x and y's. So we have x equals 1/2 y plus 9 over 2. Now we solve for our y. So we subtract 9/2 from both sides, and we have 1/2 y equals x minus 9 over 2. Now we want to divide by 1 over 2 on both sides. And so we have y equals, now x divided by 1/2 would just give you 2x. And then negative 9 over 2 divided by 1/2 would just give you negative 9. So that means that your inverse of g of x is 2x minus 9. So now we take it one step further, and this is actually the last problem in the series. They're asking you if h of x equals g, or the inverse of g of x plus k, and it's tangent to f, where do they contact? So the first thing is we want to write out what our h of x is going to be equal to. So h of x is equal to, and we already know the inverse of g of x. It was 2x minus 9 plus k. Now they're saying that this is tangent to f. If it's tangent to f, then that means that we're first going to need to find out what f is, because it's not in very nice terms. As you can see, it's 1/2 x plus 5 squared minus 8. And then we're going to need to find out what f prime of x is. So let's take a look at that. So if f of x is 1/2 x plus 5 squared minus 8, let us simplify this. So this is going to be 1/2 x squared plus 10x plus 25 minus 8. So we got this from knowing what the square of, or the sum of squares is for your polynomials over here. So if you don't remember, you can do FOIL, and if you do, it's x plus 5 times x plus 5. You do your firsts, which gives you x squared. Do your outers, which gives you 5x. Your inners gives you another 5x, which gives you 10x. And then your lasts give you the 25. So our f of x is equal to this, but we're not done simplifying yet. So we have f of x is equal to 1/2 x squared plus 5x, because 1/2 times 10 is 5, plus, and here we're going to have 25 over 2. So we have 25 over 2 minus 8. So this is going to be the same thing as 1/2 x squared plus 5x. And here we're going to have plus 25 over 2 minus 16 over 2. So we just converted the 8 into halves. And this will give us 1/2 x squared plus 5x plus, and now 25 minus 16 is 9 over 2. Okay, so now that we have this, we need to find out what is f prime of x. So f prime of x is, we take this part right here. Remember, the 2 comes down and multiplies by the half, which gives you 1. So you just have 1 times x, which is x. For the next term, we have 1 for the exponent of x that comes down and multiplies by 5, and so we're just left with 5. And then the constants, just you get 0 when you take the derivative of a constant. So now we have our f prime of x and we have our h of x. And we're saying that the h of x is tangent to f. So what that means is that your h of x has the same slope as your f prime of x. So that means that we need to put these together. So x plus 5 is going to equal, and now your slope of h of x is 2. So this means x plus 5 equals 2. So we're going to subtract 5 from both sides, and we're going to get x equals minus 3. From here, all we need to do is substitute it back in and see what we get. So remember, it's tangent to f, so it's going to intersect, or this is going to be the point at f as well. So we can just substitute this back into f. So we have f of negative 3 equals 1/2 negative 3 plus 5 squared minus 8. So this is going to give us 1/2. Negative 3 plus 5 is just 2 squared minus 8. 2 squared is 4, so it's going to be 1/2 times 4 minus 8. 1/2 of 4 is 2 minus 8, and this is going to give us negative 6. So this means that they will intersect or contact at negative 3, negative 6. And that would be your answer. So guys, this is how you solve one of the problems on your exams. As you can see, they kind of scaffold it up, so each problem kind of builds on the other. And it's important to get these correct, because if you look all the way at the beginning, knowing the coordinate of A helped you get the range of f. And then knowing that stuff helped us get the coordinate of D. Knowing the coordinate of D helped us get the area of the trapezoid. And then from there, we used G in order to give us the inverse, and then the inverse, along with knowing how to get the derivative of f, allowed us to pinpoint exactly where they would meet up for h of x. So I hope you guys learned quite a lot in this, especially how to solve these problems, how to approach them. And if you guys have any questions, please do not hesitate to give us a shout, do the Ask a Tutor thing, ask us on the live lessons, and I will catch you guys next time.